So I'm confident that you all are friends with this page. Wait for it. Wait for it. Not that one, not this one. That's chapter 9. That's chapter 11. Here we go. I'm confident that you know this page, and this isn't the first time you've seen it. And really, all the main stuff we need is these steps. Okay, I don't know what's going on there. Oh yeah, she's cleaned it up a little too. That's so nice. Okay, so let's just start.
Okay. Eric, one question. I didn't, because of how we did it before, I told them that they didn't need to do the substitution, but just to show the formula.
Yes.
So that they would know what formula they were using, but to actually get all the substitution into that formula.
Yep, I'm okay with that. In fact, like if the only substitution I think would be useful for me to see is what they typed into StatCrunch. So you show that, write down one of these two formulas, and then StatCrunch needs what? The P naught and the significance level, and that's about it. And you've written that here already, and you're writing it here already. So yeah, I agree with that. I like that.
Okay. I just wanted to be sure because I'm like, as we were doing that, I'm like, oh, you know what? I think we're okay with just, because when we get to chapter 11, that's what we're going to do anyway. So.
Right. I think you also need to put an in too, don't you? But yeah. So, yeah. Okay, so let's just do one. Shall we, from start to finish? Do y'all think you can do this? Yeah, I can get you started. So let's read the problem. Let me read it how I would read it as a student, or how I think a student should read the problem. So I'll read it, highlight the stuff, and we'll talk through it. So we got, according to the CDC, the prevalence rate. Ooh, let's pause. Do y'all remember what prevalence rate means? It's a very specific thing for us. And maybe I'll just say it. This means population. Prevalence means among all people, this is the percent that have the characteristic. So the prevalence rate of obesity in the US is 41.9%. Meaning that's the population value, or the assumed value of the population, meaning that's P naught. How do y'all feel about that?
Good.
Good. And I'm sure you caught, right, that in
they
all
told
of
us this.
Good. Okay, awesome. I'm sure that you've caught in all of these problems, you're going to get population values and sample values. You get both. Whereas in chapter 9, you only got sample values. And then you built, the sample became the center of the confidence interval, and you built a thing around that confidence interval. Well, hypothesis testing says, hey, we think we know the value for the population. We think it's this, but then we did some sampling and we got some results, and we think it's different than that in some way. Either it's not equal to, it's less than, or it's greater than. So you're always going to have a population value and then sample results. And you're testing, are the sample results, did they happen by chance or did they not? Okay, so we got the population value, and then we got a researcher for the Jackson County Health Department believes that obesity rates in Jackson County are significantly lower than the national level. Okay, so this is a keyword, significantly lower. And this national level is referring us back to our prevalence rate, which is referring us back to the population value, the P naught, 41.9%. So if you think this is a keyword, believes, what we're looking for, hypothesis tests are about claims. So this is a word that says, here comes a claim. We believe something, we're claiming something. And that's where we get the step 1 part, whether it's greater than, less than, or not equal to. It always comes in the belief statement or the claim statement. Okay, so significantly lower than the national level. All right, these researchers gather a random sample, all right, Hopefully we're all comfortable. That's our N equals 200. Random sample of 200 adult residents of the county and find that, here's our P hat, 37% are classified as obese. Now pause here and note, our claim is lower, our P hat is lower, right? So the sample result matches the claim. If it didn't, this problem would be done. Like if we claimed that it was significantly lower and then our P hat had 80%, it's like, well, you know what? Our claim is wrong because our sample did not match what we thought. Which is why when you do this kinds of stuff, you make your claim and your statement before you go gather your data. Then you go gather your data, you do your sampling, and then you test your results. So our job here is to test, is this 37%? Which is lower than the 41.9%. Did that happen by chance? Was it just an accident? And if it was just an accident, this is the level of accident, by the way. If it was just by chance, then we throw away the results and say we don't know anything. If we get a p-value less than 5%, this is our comfort level of chance. If it's less than 5%, then we say, aha, there is something happening in our little group that we looked at. The rates might actually be lower. We have evidence to support our claim. Okay, so that's our job. Test this claim. So let's do the first step. To me, this is the most important step, step 1. And this goes back to what we talked about in chapter 9, where I said there's like 5 things you have to do for all these problems. And I argue that the first thing you should identify is what parameter are you working with? Is this boy, why am I not remembering? A proportion, or is it a mean? Now, I've already stated it's a proportion, right? But remember our clues. We got a percent here. The word rate is a clue that we're talking about proportions. I think those are the 2 main ones. So we know that we're always going to have 2 statements, the null hypothesis and the alternative hypothesis. Did you all use what does she use in the reference sheet? She uses 1.
I used A. I thought you used A, so we've been using A, but it doesn't matter. I told him
Totally
either.
fine. Yep.
Yep.
Okay, so whichever one you want. Null statement, meaning no change, meaning 0 is like nothing, and change statement, 1 or alternative. Either way, the reference sheet uses 1. Does it use it in all of them? Yes. Yes, it does. So the reference sheet uses 1. It doesn't matter. Okay, so because we know it's a proportion, we're going to have a statement of P equals, and then a statement of P, and we don't know, and then we have to have the number. Remember, our value here is the assumed population parameter. Now, it feels like there's a typo here, because this P should be P naught, because that's what these P naughts are. They're the assumed value of the parameter. Maybe it's not a typo. Yeah, maybe. Okay, maybe let's. So the P here is the population parameter of interest, and then we're thinking our claim is that it's equal to this P naught, or the null statement is that it's equal to a particular number. That's the P naught, and then we're making a claim in the alternative hypothesis of one of these things: less than, not equal to, greater than. Okay, so you all tell me. Let me give you like 2 minutes. When I say you all, it's Reagan and Kayla. It's you too. You're the golden children today, or the golden adults. I shouldn't say children. Decide what the number should be and what the claim should be. Is it left-tailed, two-tailed, or right-tailed? So let me give you 2 minutes to think about it. Set a timer, 2 minutes. Love it, Kayla. Let me make sure I remember, because I don't remember left tail. I remember less than a greater than. Yeah, nailed it. Okay. So as I'm sure Cindy told you, but it always bears repeating, if you want to make sure you've written this down correctly, make sure that these two numbers match. Now, whether you write it in percent form or decimal form doesn't particularly matter. So you can have 41.9% or you can have 0.419. Either way, just know that when you type it into StatCrunch, it needs to be decimal. So I'm going to go ahead and write it here as decimal, just because that's what StatCrunch is going to want. But Kayla, you were not wrong to write it as a percentage. I would not count that off. Excellent. Okay, question. Can you all finish the test?
Sure.
Okay, let me give you like 5 minutes and we'll check in to see where you're at. So this is how I like to see students write it out, although maybe you have a better, nicer way to write it. If you're wondering what this is my shorthand for step 1, S1. And then I would write step 2, alpha equals, step 3, what's the formula, what does StatCrunch give you out, and step 4. I like to, it makes it easier to grade when it's kind of neatly organized through the steps. That's kind of what I like to see, but you don't have to do it that way. If you have a nicer way to put it together, I'd love to see what you're doing. But let's give you 5 minutes at least. I'll check in at the end of the 5 minutes to see where you're at, and then we'll talk through it. And if you have questions, if you get stuck, please holler.
So for X, we would use the 37%, Cindy. Eric, I was just saying we use the 37% for X.
You use that to find it. Remember, X equals P hat
over
N.
N. Okay.
And that comes from the fact that P hat equals X divided by N. Good. Yeah, I'm here. If I'm not in screen, I'm like right in the corner. So feel free to call and I'll come running. Although Cindy's just as good, if not better.
Reagan, you don't actually have to put in, you only need to put in X and N into StatCrunch. So you don't even need to put in your standard deviation. That's what we were saying, when you don't need to substitute those values into StatCrunch. So you shouldn't, so when you go to Stat Crunch and you're gonna do your stat.
we needed to find sigma.
Yeah, you would only need that if we do the substitution.
Okay.
So you have your formula, which is, if you go to your page, you remember it's like Z naught equals that, all that garbage. So write down your formula, but then when you go to stat proportion stat, one sample with summary. Yeah, so you're gonna need to put in. Do you see what you're gonna need now?
Yeah, got it.
Okay.
Thank you.
You're welcome. Misty, you got the page number. Oh, from Eric.
That was a little slow, but I got there.
So Eric, I have a flight today to Florida. So we're leaving my house at noon to get to the airport. I could still be on.
Oh.
But I'm not driving. But anyways, but our flight is from 3:30 until a little bit after 6. So we land in Fort Myers a little bit after 6. So I can get on tonight, but
No. Nope, you're good. You're good.
Okay. All right.
I owe you like what, 3 or 4 classes still?
No.
How are you all on time? Was that do you need another 5 minutes maybe?
I think I'm ready to start going through it.
Okay. Let's do it. So just in case someone's wondering where are we getting these steps? I am taking them right from here. This is page 275. I really think that how they're laid out here is a helpful layout for you all, and this is, you are intended to bring this to the final exam and use this as the structure to do the hypothesis test. You of course can rewrite these however you wish if you want on your personal reference sheet. I just think this is laid out so nicely. So step 1 was identifying which of these 3 things is it, and your job is to make sure you put the number in and then select the correct symbol. That's what we did already, right? Step 2 is the one that everyone should always get. What's the level of significance? It's how likely are we to make a type 1 error? That's what this alpha is. Another way to think about it is this is the threshold of chance. We're saying we're comfortable with it being 5%. It has to be less than 5% probability that our results happened by chance for us to claim it's not chance. It's not an accident. Let me try to say that better. We're saying anything below 5% for our p-value in our calculation in steps 3 and 4, anything less than that 5%, we're saying it didn't happen by chance. It isn't an accident that our 37% is less than our 41.9%. There's something happening in Jackson County that makes the levels of obesity less than that of the nation as a whole. Maybe our health department has some sort of program that, I don't know, it helps lower the obesity rate or whatever. So if we get a p-value greater than 5%, we're like, we're not comfortable with that. We're saying that the results, this 37%, happen by accident. Remember our 3 things. If we get a sample that doesn't match our expectations, either the sample itself was biased, and so the results are no good, or it happened by chance, or the parameter itself is bad, right? Those are the 3 options that could happen. And what we're saying here is this is our level of comfort with us claiming that it didn't happen by chance. Anything below this. Okay, so for step 3, we're just finding the test statistic, which is this Z naught. And I don't particularly care which of these two formulas you write down. I guess, I don't know, maybe I should care, but maybe I'll write the full one out. Notice this piece, this p hat or p naught times q naught divided by square or n. That's the same thing as what we did in chapter 9. It's way back here. Right here, except we used p hats and q hats. We used the sample values to do the spread calculation, or the standard error calculation. Whereas with hypothesis tests, because we think we know the parameter, we use what we think the parameter to be as in our calculation for the standard error. That's the big difference now. Okay, so this is let me glance it again. There we go. We got it now. It's the sample value minus the assumed value of the parameter divided by the standard error of the parameter, which is this p naught times q naught divided by n. Now, like Reagan was pointing out, we need to know x, which is the number of successes, and we need to know the number of observations. Well, that's just the 200. We got that straight from here. Unfortunately, we have to calculate x. That's 0.37 times 200. Oopsie, sorry, I hit enter. So you can type that directly in there and it will give you a calculation, but the number we're supposed to enter is 74. You don't always get exact numbers with this. If the 37 was rounded to a particular value, you have to have a whole number that you type in for x. Now notice we do need to mess with the hypothesis test. You've been comfortable with this before, right? We did this. This is the confidence interval from chapter 9, and we had to change this to match our C level. Here we need to match the assumed value of P, which in our case is 419. Notice it matches it for you. And then you have to match your claim with the claim here. I don't know why I'm lecturing this. Do we want the critical value? I don't know. We don't need the critical value. Compute, and here is your result. So Z naught is negative 1.404, I guess we'll do 3. And the p-value is this. Now, maybe I should show you one other thing, because for step 4, we're supposed to graph this picture. And we can have a graph generated for us. That's the p-value plot. Let me pause there and make sure. Does everyone see what I'm doing? I put in my x, my n, my p naught. I selected my alternative hypothesis, which notice it's A here in StatCrunch, and it's 1 in the notes. So maybe we should stick with A in our writing. I don't know, whatever's easier for you all. And then I'm grabbing the p-value plot, and the reason I'm doing this is because it will give us this graph. We just have to click over, and there's our graph. Now, you don't have to draw your graphs perfectly accurate. You do need to draw it with the shading in the correct spots, either left tail, right tail, or two tail. How are we doing? I'm like lecturing this. I don't know how to make you all say it. Is everyone 100% so far?
Yeah, this is going good so far. It's coming back.
Good, good. So here's my thing. Okay, so then what did y'all do in step 5? I think you should write this statement. This is how I tell everyone. Go ahead.
P-value is less than the 0.419.
Where'd you get the 0.419?
The PO thing.
Oh, okay. So let's be careful here. Here's why I want you to write this statement. In step 5, what we're doing is we're comparing the p-value we calculated from step 3 to the alpha value we determined in the problem, from the problem. So we want to show that 0.0801,
So the significance level is the alpha.
100%.
Okay, I didn't know that.
Good statement. Yes, I didn't say that. I forgot to remind you. Level of significance. Now, I guess it does say it here. It says level of significance alpha. Maybe there should be a comma here. Level of significance, comma, alpha, based on the seriousness of making a type 1 error. So I think you will see problems that say 5% level of significance or alpha equals this. It'll come in both of those ways. So we're comparing these two numbers. Now, look at the statement. If the p-value is less than alpha, we reject the null hypothesis. So is the p-value less than alpha? Is this statement true?
No.
No. Now, sometimes students struggle. Sometimes this is difficult for students. And here's how I tell students to look at it, because we're looking at decimally numbers that can get wonky. We don't need to look at the 0, right? Because they both have a 0 after the decimal. So the numbers we're really comparing is 8 and 5. Is 8 less than 5? No, it's not. So this is not a true statement. Oops. The way I would show it is a line through it. That's one way. You could put an X here, a fail. I think what I'd love for you to write is either reject HO or do not reject HO. I think that's helpful to write that down so it's very clear that you read this statement correctly. All right, does anyone have the sentence for the conclusion for step 6?
So we say there's not enough evidence to support the claim that the prevalence rate of obesity is 41.9%.
Okay, excellent. Yes, you, instead of putting so we didn't claim that the obesity rate was the 41.9%. We just claimed that it's less than. Oh no, you're right, you're good. No, you're good. So but we can skip the numbers in the conclusion and just say there's not enough evidence to support the claim that the obesity rate of Jackson County is less than, actually, if we were really precise, is significantly less than the national average. But you're right, that might actually be better to say than what the national average is. It doesn't particularly matter. But you do have to write either there is not enough evidence or there is enough evidence, and then to support the claim, and you can just copy and paste the claim right here. Believes that, here's the claim: obesity rates in Jackson College are significantly lower than the national average. That's the phrase that you can toss in there. All right, grade yourselves. How'd you do? 100%? 0%? Um, 99.5%. Okay, love it. My argument is always, if you've done a couple of these start to finish with 0 help, you're good. You're going to crush the final exam, or at least this portion of the final exam. There's still confidence intervals and some other stuff. Okay, let's do some of the little pieces here. So take a minute and answer number 2. Oh, well, actually, I didn't give anyone chances to ask any questions. Does anyone have any questions about our write-up of the test from start to finish, steps 1 through 6? All right. I mean, like, I didn't wait super long, but I don't want to waste our time. So let's take 2 minutes and you all answer number 2. Read that carefully. We got a two-tailed test. That's key. It's important. A two-tailed hypothesis test. So these are the z-values for each of those. The question is, which one will have the smallest p-value and which will have the largest? Try that, and then let's talk about it. Set a timer 2 minutes. Okay, any thoughts? Let me just show you something you could do with this. This is a between. So we could put in a 0.13 and a 0.13 in here, and we could actually calculate the area. Now this is problematic because let's just, we don't have to do between. We could just do less than negative 0.13. There's this p-value. This has a p-value of 0.097. Y'all with me on that? We could do a less than on that negative 2.4. That has a p-value of 0.008. Now for the positive ones, we have to do greater than. So 0.054. Y'all see what's happening here? Is that what you thought through?
I was just looking to see like how the two correlated with each other, because I was kind of thinking that it was like the p hat and the x and the n, where it's like you can all like switch it around and find the other thing. So yeah.
But you can't, right, with these, because if you look at the formula,
Yeah.
you've got
Yeah.
so many unknowns, a p hat, a p naught, and an n. We've got 3 things we'd have to find, and we know none of those. Yeah. So really, this is just getting at when we have a z value. So these are z-scores is what they really are, back from chapter 3. Which one has the most area to the right of it or to the left of it? So because it's a two-tail hypothesis test, we know that the positive number up is going to be here, the negative one is going to be here, and so it's either this area or this area will be the p-value. So the further away we are from zero, the larger the critical value is going to be. But this isn't critical, I'm sorry, the Z naught, the test statistic. And the further we are away from zero, the smaller the p-value will be, the less area you will see to the right or to the left. So one of the connections this problem makes is that positive z-values are right-tailed area. Negative z-values look at left-tail area. So larger z-naught values will correspond to smaller p-values. Smaller z-naught values will correspond to larger p-values, and we don't care about the negative sign. So what's your answer for A? Which one has the smallest p-value? It is studied. Nice. Good.
And B?
And then B is the largest. Wait. The largest p-value. Yeah, A.
I got A.
Good. So you don't need to do what I did here, where I found all the p-values. You should be able, the hope is that you'd be able to look at these and say, oh, 2.7 is larger than 2.4. Who cares about the negative? So 2.7 being the largest z value will have the smallest amount of area to the right or left of it. And then negative 1.3, ignore the negative, 1.3 is the smallest z value of all of them. Thus, it will have the largest p-value, the largest area, which is what p-value is equal to. Okay, good. Hopefully that feels all right. Now, how'd you all feel about the error stuff? Do you have your little table and know which is which? This would have been 10-1. This is always super confusing. I think, but maybe you all just crushed it. Nope, that's the decision-making process. Here it is. This little table, I think, should be in your reference sheet. A type 1 error is rejecting HO when we shouldn't. And a type 2 error is not rejecting HO when we should have. So suppose we can't answer. I'm sorry, we can't answer this one. All right, so let's start back at the beginning and let's run through this problem from start to finish. Notice that this is just a hypothesis test where we've given you the output already. And then we're like baby stepping you through it with a few other extra things, right? Like this is step 1. What are the researchers' hypotheses in both symbols and words? What type of test is this? This is also step 1. What's the population size? This is identifying things. This is verify the requirements. Yeah. Okay, so let's take 5 minutes on the first page. I want you to read it and figure out what are the important things up here and read this carefully and figure out what's there and then see what you can do to answer it. And we'll check in 5 minutes. Do you all think you can get started? I'll take that as a yes.
I'm just getting on, Eric.
Welcome, Laura.
I thought the Chelsea Treehouse was open. I drove all the way to Chelsea so my daughter could play because I found out she didn't have school when I got there today. So we're on page 687.
687, there you go. Welcome.
Okay.
I'm sorry. How disappointing.
Yeah. All right.
Is it like all schools are closed today? Did they pay the ransom, or is it like
GSRP preschool is not open today because of conferences for the week. They didn't announce that until last night, and I was too busy doing other things to check all, all my stuff.
Yeah.
But anyways, yeah. Okay, let me get started on this.
We're glad you're here. Try this out.
But they are back in school, Eric.
Did anyone say what they did?
They did not pay the ransom.
Oh, good, I guess. Yes?
Yeah, good.
I think so, yeah. Awesome. Okay, I'll be quiet and let y'all work.
My parents are teachers at Springport and they can't even like bring their phones to school, or it's like insanity.
Do they get like wanded as they walk in? Like,
I don't even know, but they're like, all the students are like, do not even bring them because then it could put us all back at square one. It's insane.
wow, wow. Yeah, it's a cyber world we live in. Okay. I'll reset the timer. Reset the timer. Oh, wait. Set a timer for 5 minutes.
Eric, I got to G and now I'm kind of stuck.
You're stuck on G?
Yeah, well, how the sample proportion is
Isn't that X divided by N?
X divided by, okay.
Do we know
So
X and N? Oh, go ahead.
X would be, well, N is the 32, whatever, 32,098. So the P, the
Careful.
51.1% is the PO thing,
Good, good.
right? So
But-
the, okay, I don't know.
Well, hang on though. If you're saying that P naught is 51.1%, notice that 51.1% is of the 32,000 children in the
Right.
Grand Rapids school. This is capital N.
Right. So
We want lowercase n.
in the lowercase n,
Look at your readout down here. It's in this readout or
the
printout.
total,
The total?
yeah.
Good.
So that would be the answer for E.
Well, what's the X though? Oh, yes, that would be the answer
Okay.
for
So
E.
then it would be.
No, hang on. E is how many? Oh, yes, that's 172. Good. Thank you. Go ahead.
So 172 over the 32,098.
Oh, no. Remember, it's X over N.
Oh, so it'd be,
The count.
Good. The count is X. It's a weird way to say it, right?
right.
This count
So,
corresponds to the number of successes in the part where you would have typed it into StatCrunch.
So 172 over 32,090. That's not right.
That's not right, because that's the sample size relative to the population. You would need that for verifying.
Right. That's what I'm saying for G, right?
No, for I. For G, it's like, what's the sample proportion? That is X, which is the 105, divided by N, which is the number of people we talk to. So if you see what's happening, they randomly selected 172 students out of these 32,098. And they said, do you have free or reduced lunch? 105 of them said yes. The other group said no. The other 67 students.
So 105 over 172.
Yes. Does that make sense?
Yeah.
How about the rest of you all? Are you all feeling okay about that? What'd y'all say for A? Why is this observational and not an experiment? Just to check in on some of that stuff.
It would be unethical to like assign people free and reduced lunch.
I mean, like, who's going to argue with getting free or reduced lunch, right? So I don't know necessarily if it's ethical or not. It's more that that's what they did with COVID, right? They're like, everyone's on free and reduced lunch. In Michigan, at least. Lunches were free for everyone. Really, it's free and reduced lunch is tied to your income. And so you can't randomly assign households in an income. Like, it's just impossible. But yeah, you're on the right. You got the right idea. We can't assign household income. We could, as a society, just decide that all kids that attend school get a free lunch, regardless of your income. It would be simpler for schools because they wouldn't have to track everyone's income and prove it's this and that and whatever. But it might be kind of costly. I don't know. Okay, what did you all say for the researchers' hypotheses? Did you just copy and paste this?
Yeah.
Good. And so the words are, the null hypothesis is 51% are on free and reduced lunch, and then the alternative is that it's not equal to 51.1%, making it a two-tailed. Okay. Does everyone feel okay with these, with this first page?
Yes.
I'm good with it.
Okay. Are you all able to do from H on? Should I give you 5 minutes to do that?
Yeah, please.
Set a timer for 5 minutes. Done. So that was 5 minutes. You'll need more time, or was that enough?
I'm trying to find the formula to figure out H. I know that it's somewhere, but I haven't found it yet.
Well, let me show you. So there's bunches of places you could find it, but I think the best place for this particular one, so all the symbols match, is for the page for hypothesis testing, which is the reference page is what I'm referring to, page 275. The problem is it's not like, well, it's kind of shown right here. Here is the standard, the symbol for it, the standard error. Here is the formula for it, which is the same formula you saw back in chapter 8 and the same one we used in chapter 9. It's just we're using a P naught now. So this P subscript 0, as opposed to P hats or P's. Now, really, the P naught is the assumed value of P. So it's really the same formula written in chapter 8 for the central limit theorem, but this is what that's what you're using.
Okay, pause 1 minute. I gotta grab my other book.
Yes, let me pause. I am happy to pause.
Okay, I found it. Thank
Nice.
you.
You are welcome. Anyone else stuck on any particular part in here?
I'm just getting through J right now.
Okay, let me do 5 more minutes and I'll check in. I want to give you plenty of time. Set a timer for 5 minutes. Okay, where are we at?
I'm ready.
I'm as ready as I'll ever be over here rolling snakes with Play-Doh.
Nice, love it. That's the good life. Okay, so for H, we need what P naught is. Are you all comfortable with that being 0.511? It's always in step one. That's where you get your P naught. That's where it's used. It was told here, it's reiterated there, right? Good. So Q naught is just its complement, which is 0.489. And then the N we already identified up here, right? So the standard error of the P hats, I'm sorry, of P hat is equal to, really that feels like a typo, doesn't it? Because it's really the standard error of the P naught, but we're using this kind of as the estimate, and it's a little wonky. So 0.511 times 0.489 divided by 172. Anyone have this number? So I don't have to type it in anywhere.
I ended up subtracting that, so I'm reworking it.
Okay, no worries. You did 1 minus 0.511, right? So
I did 0.511 minus the 0.489. So we're supposed to times it, not subtract it?
yes, if you look at if we look at the formula for calculating the standard error of the P naughts.
Oh, gotcha. I thought that was a minus, not a dot, because it's so far away. Okay.
Gotcha.
Same for me. That's what I thought too.
Well, I'm glad we did that.
I got 0.00145.
Nice. That feels good. What's this? Oh, there's a global math art contest. If y'all want to see this done in Desmos, I'll do it in Desmos here. Oh, maybe I should do the thing that makes it easier. I would put in the square root symbol first and then make the fraction. Remember that? Like there was.
Oh, I did not square root that.
Oh, okay. Okay. Good thing I'm typing it in. So it's a little bit larger of a number. If you think about, if you remember standard error 1, 2, 3, 4, 5, because of 5 decimal places. Standard error was used in the confidence interval, and that's kind of where this is here too. So you can check the reasonableness of your answers, I think, by thinking about that as this would be the plus and minus from around the P hat. Now it's different because we're working with a hypothesis test, not a confidence interval. But the results of the confidence interval and the hypothesis test will match. Like the confidence interval will support the claim. If we made one, it would support the claim if we had statistically significant results, meaning if we rejected HO. And it will contradict the claim if we fail to reject HO. So that part matches. Any questions on this? Everyone feel good about what's happening here? Yeah, I see. Right.
I'm good. Silly mistake.
Okay. Yep. That's a quick fix, right? Now we know the formula. Good to go. You noted, hopefully you noted, there is a slight difference with the requirements for the test. Notice what you use for normal. You don't use the sample value. You use the assumed value of the population. So you use the P naught, not the P hat. That's different from confidence intervals. When you do the chapter 10 project, this is the most common mistake I find on the chapter 10 project. People use the P hat and the Q hat from their Skittles and M&Ms, as opposed to using the presumed value of an H naught, as opposed to using this. So C1, random given, right? Everyone's happy with that. Random given. C2, this one you would take your 172 and you'd want to show that that's less than or equal to 0.05 of 32,098 because we know that number this time around. I guess that's close enough that maybe we should check it. Maybe it's not obvious, which is 1604.9. Yep, that's good. 172 is way less than that 1,604.9 students. I'm doing this fast. Is everyone good? I'm assuming you have.
Yeah, I got the same thing.
Yeah, I'm good. I got the
Good.
same thing too.
Yay! Oh, you're so ready for the final.
To get it over with, yeah.
We are so close, y'all. 3 weeks after Thanksgiving, and it's done. Hang in there. You can do it. Don't peter out now. This is the hardest time to stay in. I get that. Okay, so then this is 72, and here's the difference. We're using these two numbers back from H for the condition of normality. So I'm getting that it's 42.98 is greater than or equal to 10. So that's met. Check. Okay.
That's what
cool.
I do.
Excellent. So it says use the computer output to perform the next two steps with, here we finally get alpha or the level of significance. So step 4, remember, is the graph. We know this is two-tailed because it said it. Right here. We know that this Z value, this is the Z naught. Did you all know that? Z stat is the same thing as Z naught. And this P value is the combined area in both tails. So if you look at the graph here, this is how we graph the two-tail test. So we would do, oops, I got to memorize this number, 2.61. So we'd have a positive 2.61 here, a negative 2.61 here, and then our area is 0.009 something. Let me go back and make sure I know that, 0.0091. And that area is the sum of both of these two tails. Is that good for step 4? Is that what you all had?
Yes.
All right, excellent. For step 5, I really encourage you to write this, the statement that we're checking. If this is true, then do something else. Put in our P value 0.0091, put in our alpha value 0.05, decide, is that true? If it's obvious to you, awesome. If it's not, I'm going to underline the first non-zero number that they both have in common in digits. So when we go 2 decimal or 2 places after the decimal, I'm comparing 0 to 5. Is 5 bigger than 0? It is. So we reject HO. Because we have, what this is saying, it's like a 0.9% chance that this happened by accident is kind of one way to read that. And we're comfortable, we're like, hey, there is a, what are we saying here? That value has changed since that time. And because our P hat is actually higher, it's suggesting that the value has increased. 105 divided 172, whoops, 172 is equal to 61. So there's a 10% difference between what it was the previous year and in the new year, in this new whatever. Okay, so suppose the percentage of students in
So
grant,
it's rejected even though the 0.05 is bigger than the 0.0091?
yeah, great question. I'm glad you asked that. So that's the criteria. If the statement is true, if the p-value is smaller than the alpha, then we reject HO. If it's not, if alpha is not sorry, if the p-value is not larger than alpha.
Okay.
So if it's helpful, you could write this: p-value greater than alpha means do not reject. Go ahead, I cut you
it's
off.
just kind of backwards. You would think that like if it is bigger than it would support. Okay, I get it.
So the thing to think about is, what does alpha represent? This is our threshold of it happened by accident. We don't want our sample size results to be accidentally happening. Because if it happened by chance, then whatever our numbers are just, it's just an accident. There's not something in the population or in the sample causing it. What presumably we're measuring is incomes have decreased for families in Grand Rapids Public School. So the family, the median family income has gone down, meaning there's more children that qualify for free and reduced lunches. That's not necessarily a good thing. We want families to not qualify for this, meaning they have enough resources to comfortably support everyone in the household. The children are eating good meal, 3 good meals a day, whereas this suggests maybe there's a need for help. And if you've listened to anything in the news, like this is across the board, everyone is kind of in trouble financially, or what used to be the middle class is struggling to provide. Okay, so now we're saying, hey, let's ignore what happened here. Let's say that we shouldn't have rejected HO. That's what this is saying. So we got these results that say, oh, it's actually changed. So it's no longer 51.1% based on the evidence from our sample, but something happened in our sample. It's not true. What error did we make? Type 1, type 2, or correct decision? Notice if this is actually the P naught, then the decision we should have made in step 5 would be do not reject HO. What'd you all say here? Type 1 or type 2?
Would it be type 1?
Yes.
Okay.
Yep.
Yay.
That's kind of, yeah, you did it. That's kind of like the little thing. If you reject HO when you shouldn't have, that's a type 1. If you fail to reject HO when you should have, that's type 2. That's kind of like a shorthand way to do it. Okay. Should we all stop and do like 5 push-ups to reset our brains, maybe, or 10 jumping jacks, or 15 squats? I don't know. I'm making up those numbers. We've just completed the worksheet number 2. I think we've done the whole thing. This is the 033 worksheet for Cindy that I guess is due Sunday. And then we now have my worksheet to work on, which is the 133 number, or for 133. And I kind of want to just start with, let's do it all again. So I kind of want to go straight to question 692, or the question on page 692. And I want to see if you can just put it all together. Every final exam I've administered has 1 or 2 of questions like this on the final exam, just a big, a paragraph prompt, and then you just do it. And they're usually 10 to 15 points on the final exam. So it's like 20% of your overall final exam grade is, can you do 2 different hypothesis tests from start to finish? You have learned how to do 1 test, a proportion. Tomorrow you'll learn how to do the mean test. And then in the final weeks, we'll do it with 2 samples. So we'll be comparing 2 proportions to each other. The structure of all of them is exactly the same. The 6 steps, there's 6 steps you go through, you state the null and alternative and all the rest. What's different is how we state the null and alternative, and then step 3. So this step is different for each one, and this step is different for each one. Everything else is exactly the same. This stays the same, how you state the conclusion, how you draw the graph, how you use the level of significance. So if you can do one of them, presumably you can do all of them. It's just keeping track of the little bits and pieces that help you determine which test to do and how to do it. So let me give you 5 minutes. Are we all on the same page for number 5?
Yay, let's do it.
Let's do it. I want you, so after 5 minutes, I'm going to check in to see if you have steps 1, 2, and 3. And if like that's too fast, we'll pause and do more time, because to me, the most important step is step 1. If you can identify that, the rest works. Because if you screw up step 1, like if you have the wrong test here, then what you put in StatCrunch is going to get you the wrong answer here. Okay, 5 minutes. Set a timer for 5 minutes. Crush it. Okay, that was 5 minutes. Let's just check. What do you all have for step 1?
For HO equals 0.91, and then HA is greater than 0.91.
Does everyone agree?
Yay, I did that part right.
Okay, good. Let me just, in case someone else is wondering where that came from, we've got researchers, blah, 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 found that 91% of Fortune 500 companies had Twitter accounts. Notice there's an implied all, right? So that's a population value. That's what you're looking for, that this is the presumed value of the population. And then here comes the claim. This is the key word you should be looking for. Believes or claim or something that the Twitter usage rate is higher. That's how we knew greater than. Excellent. I guess let's check for step 2. What'd you all say for step 2?
I did 0.96 times 150 and got x equals 144.
Ooh,
And
that's for step 2?
Oh, to find the, oh, that's the significance level, which is 1%. So it'd be 0.01
Good,
for sigma.
good. So then step 3, you're telling me to get your number of successes, you had to do this.
Right.
0.96, which is the p hat, times the 150. And that's also saying that n equals 150. Okay. How much more time do you all think you need to finish this up?
5 minutes.
Okay, let's do 5 minutes. Is everyone good with what we have here for steps 1, 2, and 3? Step 3 isn't finished. You still got to put it in StatCrunch, whatever this is and that. But is anyone unclear on what's happened with these 3 steps? Okay, set a timer for 5 minutes.
Where am I going in StatCrunch? It's stat, summary stats.
Proportion stat, one sample with summary.
Stat, proportion stat, one sample with summary. All right, thank you.
And in case you forget that in the future, it's right here on the top of your reference sheet on page 275.
And N goes in number of successes.
X is successes and N is observations.
Okay, that's why it's looking wrong
Yeah.
to me. So X is success.
Okay, that was 5 minutes. 5 more minutes. How are we doing? A little better?
I think I'm okay. Moving slowly, but I'm getting it.
Yeah,
That's
I think
okay.
I'm ready to go over too.
It is totally okay to move slowly on this. All right, so I'm just going to write down the formula here so we can we know that. This is just a copy and paste thing, but really what we need from all this is the result from StatCrunch, right? So that's the stat proportion stats, one sample with summary. I calculated the X. It turned out to be 144 exactly. The N was the 150, and our claim is the 0.91. And then, I'm sorry, the P naught is the 0.91, and then you had to change this to a greater than symbol. Remember I said you don't have to do this, but it might be helpful to select a p-value plot so you can see the graph. For step 4, compute, and the result we wanted from here is this z-stat. So our z value, our z naught, or z stat is approximately equal to 140, because of the rounding to 3 decimals. I am not particularly picky about what you round to on these. What we really need is enough decimals to compare the alpha to the p-value. That's what's most important, because that's how we make our decision. Step 4, I'm just going to write this out so you all can check your work. I know I've kind of been straying away from that some in the past, because I know there are, I don't know. Anyways, this time I'm going to do it. I'm going to try to draw a nice picture. It fails. It's just failing every time. This is a positive z value, so it's and this is a right tail test because of greater than. So we know this goes up here. This area is the 0.0162. I could click the over, and there I can see the graph with the p-value and the z-stat written there. All right, so you all tell me, what'd you do? Did you reject HO or fail to reject HO?
I did the do not reject because the p-value was greater than the alpha.
Okay, let me quick fix the mistake I made here, right? The alpha. Okay, yeah, good. So 0.01, 0.0162. Is this is 0.1602 less than that? It is not. So do not reject HO. Now notice we had a much higher, our threshold of chance is much higher. When we say we just want a 1% chance of it, like that's the line between it happened by accident or it happened, it actually happened because something's different. We were much more concerned about having the wrong result. So we're more likely to make a type 2 error with this higher alpha than a type 1 error, right? Remember, that's exactly what alpha is. It's the probability of a type 1 error. Probability of type 1 error is equal to alpha. And so we've picked this to be a really small chance of making a type 1, which ups our chance of making a type 2. Remember that inverse relationship between alpha and beta, or the probability of making type 1 versus probability of making type 2. Okay, so if I were to write out the result, I would go to this sentence. Those same researchers believe, and then I'm just going to copy and paste the rest of this. Now, we have to attach it to the previous one. It's going to be, so this year is too vague. I'm going to say is higher than 2019. That's how I'm going to fix it. This is an old problem, clearly, because this year is probably meaning 2020, and we're now in 2022, right? So let's type it out. There is not enough evidence. I think in the notes, the word is sufficient. I just think enough is a cheaper word than sufficient. There's not enough evidence to support the claim that, and here's where I start right after believe. Often the word that is right there. Researchers believe that Twitter usage, Twitter usage rate is higher than the 2019 rate. Now, I would guess, if you all have been following what's going on with Elon Musk and Twitter these days, this might have changed. It seems like Twitter could die based on his takeover. Who knows?
So
All
Eric,
right.
there's
Talk to me.
not enough evidence, even though because we don't reject it.
That's right.
So when we don't reject it, there's not. When we reject it, there is.
Yes.
Hey, makes
Which
more
is
sense.
nice, right? That it's
Yeah.
consistent.
No and no. Yeah. Okay.
Not and not. Yeah, it's really good. Good. Okay. Did you grade yourselves? Let me point something out. All right, we still got 14 minutes, so we got some time to do some other stuff. But remember, at the end, you're going to be turning in for credit. You'll be receiving a grade, and it's really a significant grade, the sample final exam. I want you to note that on the sample final exam, there are some hypothesis tests you get to do. Wait for it. Here's one. Number 22 is a hypothesis test on page 756. And and page 760, there's a hypothesis test. So there's two hypothesis tests that you're going to do on the sample final exam that you get graded on for correctness, and it also goes towards your final exam grade. Okay. Any
How much
questions?
does that one count towards our final exam?
Same as the sample midterm.
Did you review the sample midterm stuff yet?
Yeah, I've thought about it. I haven't entered that in. I put in anyone who didn't turn it in yet, I put in zeros. I I suspect if you watch the videos, everyone should have 100% on it. And so if you know you did that and you know you did the work in class, you know your midterm grade will go up like 4%. That's what will happen. I am not in a rush to raise people's grades because I know at the end of the semester, a raised grade always feels good. But maybe I should get more in a rush on that because I know there is grumbling afoot.
Oh, I'm good. I passed it. That's all that matters to me.
Well, no, and I sound like I'm bothered by it. It's a legitimate frustration with me. So I don't want to discredit. If anyone is upset that I've been very slow at grading, you have the right to be that. Feel free to share that with me. That's often good motivation to get me to just finally do it. Your grades should be updated for the worksheets and the projects. All of that should be in. I just need to copy over your stat lab grade, which I kind of am waiting around on that a little bit. And then change the sample midterm. Those are the two things. Okay, so let's take the 5 minutes, or let's take a little time to talk about language still. Does everyone know what statistically significant means?
That it's current, it's significant, it's present. I don't know.
Good guessing. It's a very specific thing. It's a very specific thing. It's this. When we say, are the results statistically significant, we're really asking, is the p-value less than the alpha? That's it. So another way to put things together is, if this is true, remember that what we do, we reject HO. So what statistically significant results are samples where when we do the hypothesis test, we are able to reject the null hypothesis at the selected level of significance. So that's all it means. You might want to put that on a reference sheet. Statistically significant is the same thing as having a p-value less than alpha, which is the same thing as rejecting HO. So what's your answer to be? If the p-value is equal to 0.03, are the results statistically significant at an alpha equal to 0.05 level? True or false?
I think it's true because 0.05 is the alpha is greater than the p-value.
Good. We don't have to state why it's true, but this is why it's true. 0.03, which is the p-value, is less than the alpha. Good. See you, Kayla. Excellent. So this one's true because of this. Note that this question A is the same question. If the p-value of 0.05, then the null hypothesis is rejected at this level. Well, to reject HO, you have to think through this. So what do we say to A? Is that true or false?
It's false because, yeah, p-value, you reject when that's true and it's not true.
Nailed it. 0.03 is not less than 0.01. So we should not reject. We should fail to reject or do not reject HO at that level. Good. So notice what question 1 is getting you to put together is these 3 statements. By the way, HO, remember, in words is null hypothesis. I guess I could just box this in and say, hey, look, this is HO. So that's the other challenge of the final exam, is making sure you know the vocabulary. I think I know at least 2 of you or 3 of you can do this hypothesis test from start to finish based on just what I'm hearing you saying, just because you're responding. I'm hoping all of you were able to do the hypothesis test from start to finish. The other challenge is knowing all the little language parts. Okay, what about the last one? P-value 0.03 is less statistically significant than a p-value.
True.
This is a tricky one.
No,
Notice-
it's not. It's false.
Right. We're comparing p-values, and the smaller the p-value, the more significant the result is, because the further away from the alpha we are. So yeah, it should be false. 0.03 is not less than 0.04, but be careful. These could both be not statistically significant. Like if alpha was equal to 0.01, neither of them are significant, right? Both of them would fail to reject HO. If alpha is 0.05, then they're both statistically significant. What we're being asked here is which one is more statistically significant, essentially which one's more statistically significant. But the statement is that the smaller one is less than the larger one, which is not true at all. Maybe we should say smaller p-values are more significant. Excellent. All right. How are we all feeling?
Good.
Good. All right. Now we did not finish this worksheet, and we got 6 minutes left. Note number 2 is just, can you do step 1? Awesome, Misty. Part B is really step 4. Can you associate the p-value with the z-stat? Remember this, the larger this test statistic, the smaller the p-value. Ignore the negatives. Nikki, I don't think Cindy is here. She is flying to Florida.
Gotcha. Okay, sorry.
You're good.
I'll-
You're good.
Email you guys then.
If you can talk to me if well, I'm gotta go to class after
We
this.
have to go to class. Yeah, I'll just email you.
You can do that, or you could also, if it's urgent, you really want to talk to Cindy, you could send her a remind with that. Like you can send it to just her.
Okay.
She'll be on the road, so I know she'll be able to call you if you want.
Okay, no problem.
But emails are good too.
Okay.
Okay, this is more language stuff. Let's see. Here, look, step 1 again. Here's the verifier of the requirements. And okay, so number 4 is a hypothesis test from start to finish. Essentially, we've just added in, this is steps 2 through 6 with a verifier. So I think I'm going to let you all, well, I know I'm going to let you, we don't have time. I'm going to let you all finish those. And on Monday of next week, we can go over them if need be. I know Cindy would probably be happy to talk about them tomorrow. Well, we'll have to see. If you don't have time to look at them tomorrow with Cindy, bring them to class on Monday or email me some questions. So what questions do you all have for me in these last 4 minutes? Anything you all need?
So for this week, all we have to do is these 2 worksheets. And do we have anything else? My stat lab or anything?
That's a great question. I would guess for Sunday, you would have the 10-2 my stat lab due. Tomorrow, I'm pretty sure Cindy's going to look at 10-3. So you're just going to fill in the notes for 10-3. And then on Monday after Thanksgiving break, we'll go through the work of it, going through the worksheets to practice. We don't really expect you to do anything over break, but yeah, 10-2 is assigned for the 27th. So your goal, hopefully before Thanksgiving break begins, you'll have 10-2 squared away. Does that sound good, y'all?
Sounds good.
Just a reminder to everyone, even those that watch the videos, due dates in this class are flexible until like the 18th. I think I'm gonna, for 133, that's gonna be the final day for everything with one exception. Nope, that might be everything. There might be no exceptions. I'll start advertising that so people can know. You can see, right? We have Thanksgiving break this week. And then we get back and we have 1, 2, 3 weeks, and then it's the final exam. And I believe, oh, you know what? I might be a little crazy because I think, when is the last day of class? Is it the 21st? That seems late. I guess it is. Let me double check that. Now I'm not confident.
No, the last day of class is supposed to be the 17th. So I thought we were having our final on either the 14th or.
Absolutely correct. That's
Yeah,
what
I
it is.
had it written down for the 14th.
Yep. I got crazy here. So
We
the
do
final-
not need one more week of this class.
fair. Actually, the final will probably be held on the 16th.
Okay.
Because the last day of class is the 19th. The last day of the semester is the 19th. So we could reserve the 14th for review. But we can always discuss that.
You're looking
So
at
can-
November, Eric.
Okay, let's try again. Okay, so the 14th is going to be the final. Hey, you all knew it, just don't listen to me. So the due date will be the 11th. That will be the hard deadline. The only thing that you would have left, the reason I would do that is so that the only thing that's left is the final exam. Everything's turned in. All you're doing is reviewing for the final. Okay, y'all, have a great
All right.
day. Have a great Thanksgiving break. We'll see you. I'll see you on Monday of next week, and Cindy, hopefully we'll see you tomorrow.
All right. Thanks. Bye.